Okay, guys. Today we are looking at special kinds of factoring. Y'all need to get quiet. Special kinds of factoring. One of those cases is called the difference of two squares. As quickly as you can, Francesca, I need you to copy these perfect squares into your notes. This will help you not only with today's lesson, but also when we do that simplifying radical stuff. You really need to be familiar with perfect squares and what they look like. You also need to be familiar with the terminology. For example, if I asked you for the square root of 9, what's the square root of 9? 3. The square root of 9 would be 3 because 3 times 3 is how you get a product of 9, the perfect square of 9. Okay, so if I asked you for the square root of 9, you would tell me 3. What if I asked for the square of 8? What's the square of 8? 64. Anytime you square something, of course, you create a perfect square. And squaring and square rooting are inverse operations. So if I ask for the square of 9, that means you're supposed to take 9 and square it. That's 81. If I ask you for the square root of 9, that means what number times itself is 9, which is 3. So two very different things. What's the square of 24? 576. What's the square root of 400? 20. All right, I'm going to pause and give you guys a minute to copy this. You want to keep this in your notes somewhere where you can refer to it for tonight's homework. It's going to make tonight's homework super easy. And for sure, you should know 1 through 12 by heart. And on a test, when I'm not letting you use the notes, you will be able to use a calculator. You could recreate this list very easily with your calculator. Or if you're not sure if something's a perfect square, try taking the square root of it and see if you get a nice whole number. Okay, I'm pausing so you can copy. Okay, if you didn't finish copying, you can finish making this list with your calculator. That's all you need is a calculator. You can recreate this list on a quiz or a test. Today, I want you to have this out while you do your lesson. I'm going to show you the difference of two squares first. And I'm betting that you're going to figure out a shortcut to this process that's going to make your life much easier. Okay, first of all, this is one of those special cases for factoring. All the problems that we've done so far, we're taking a trinomial and we were splitting it apart into two binomials. Well, this is a little bit different. Our directions here are to factor x squared minus 16. Doesn't this look different than the problems you've done for the last 2 nights? What's different about it? It only has 2 terms. Okay, what's missing? What part is missing here? What number, though? Remember, our format is ax squared plus bx plus c. There's no middle term. The x term is missing. We have an a, we have a c, but we don't have a b. What's the value of a in this problem? 1. What's the value of c in this problem? Negative 16. Remember, a is always in front of your x squared, and in this case it's a nice invisible 1. B is always in front of your plain old x, and that's what we're missing here. And c is always the constant at the end that doesn't have any letters with it. So what we're missing is the middle term that with the plain old x. What if I said I'm going to force you to write it in there? What would you have to put? No. 0 x's. There are no x's here. And what number mathematically means nothing? 0. So another way to write this would be x squared plus 0x minus 16. Now, does that look more familiar? Yes. What happened to the middle term, in other words? It's not there because what happened to it? Somebody said it. It got what? It got canceled out. Sometimes when you add things together, or subtract things actually, don't they end up being 0? Okay, so let's think of the factors of 16 that could make that happen. Again, you always want to multiply a times c. Well, in this case, a is a nice invisible 1 again. So 1 times negative 16 is, wow, negative 16, right? So we're looking for a product of negative 16, which tells me the signs have to be different. So that could be 1 and 16, 2 and 8, or 4 and 4. What's the winning pair? Has to be 4 and 4. Has to be, because that's the only two numbers that can make a 0 in the middle if one is a positive and one is a negative. And how does 4 relate to 16, by the way? It's the square root of 16. Okay, so we're going to write this as x squared plus 4x minus 16. And sure enough, that cancels out to a 0x in the middle, which is what happens here. What's the GCF of the first pair? X. Take it out, and what are you left with? X plus 4. What's the GCF of the second set? Negative 4. Take out a negative 4, and you're left with? You're left with x plus 4. You remember, these are supposed to match. If they don't match, then something went wrong. And they do match here. Because negative 4x divided by negative 4 is positive x, and negative 16 divided by negative 4 is 4. Now I take out the whole x plus 4 factor, and what am I left with? X minus 4. So this factors into x plus 4, x minus 4. That's my winning combination of factors. And what happened to the middle term in that problem? It cancels out. If I multiplied those factors back, I certainly would get exactly what I started with. I would get x squared minus 4x plus 4x, and then I'd get a negative 16 on the end, and sure enough, those two in the middle cancel out. Okay, so keep in mind of what our question looked like and what our answer looked like, because I am going to allow you to do a shortcut on these problems. Yes. Yes, we're going to do that in a minute. Okay, next problem. How about x squared minus 49? Again, what's missing here? The b value. Could I rewrite this and force there to be a b value in the middle? And what would it be? X squared plus 0x minus 49. Here's where this process is much faster than normal, because I don't have to go through all the pairs of 49. 1 and 49. 3. It's got to be 7 and 7. What's the square root of 49? 7. So the pair that's going to make a negative 49 is going to be positive 7 and, not 14. A negative 49 would be positive 7 and negative 7, and it adds up to 0 x's in the middle. So we could write x squared plus 7x minus 49. What's the GCF of the first pair? X, and you're left with x plus 7. What's the GCF of the second pair? Negative 7, and you're also left with x plus 7. Factor out an x plus 7, and you're left with x minus 7. Okay, now, are you noticing a relationship between the question and the answer? Is there something we could do to kind of eliminate some steps here? Okay, if you don't have perfect squares, then you can't do this. Then it's not factorable, really. This is a special case. Not everything you encounter is going to be factorable. Right now, everything we do is going to be rigged to where you can factor it. I'm trying to see if you guys can recognize a shortcut so I don't have to go through that whole process that I just did. Looking at this, can you figure out what the final outcome is going to be? So it's going to turn into x plus 6, x minus 6, and I don't even have to go through that process. Now, on this section, if you recognize perfect squares, I'm going to let you go from here to here. Now, how do you do that? Again, this is a special case. First of all, it only works if it's a difference, which means you're subtracting, of two perfect squares. X squared is a perfect square. What's the square root of x squared? x. 36 is absolutely a perfect square. What's the square root of 36? 6. So this is definitely the difference of two perfect squares. I can skip that whole process. If I recognize, hey, those are perfect squares that are being subtracted, all you got to do is take the square root of each term, put a plus in between them, and put a minus in between them. The square root of x squared is x and x. The square root of 36 is 6 and 6. One's a plus, one's a minus. Boom, we're done. Now, I do want you to understand why this happens. What happens here is that there was a middle term of 0 x's, and the only way you're going to get a 0 x in the middle is if your factors are the same except for their signs. This gives you x squared minus 6x, then you get a plus 6x, and then you get a negative 36 on the end, and sure enough, those two in the middle cancel right out, and you have exactly what you started with. But look how much easier the factoring is. Here's the problem with the difference of two squares. A week from now, when I give you a quiz, and this is mixed in the middle of a bunch of other stuff, is recognizing it when you see it. Okay, now how can they make this a little bit more complicated? Well, what if we did this? 4x squared minus 81. Now let's put a number in front of x squared. We could go through that whole process where you multiply a times c. Use your calculator. What is 81 times 4? Or negative 81 times 4? It's negative 324. Is 324 a perfect square? Yes. Yeah, take the square root of not leave off the negative sign, but just take the square root of 324. And what is it? Okay, so two perfect squares multiplied together always give you another perfect square. So what this would break apart into would be 4x squared plus 18x minus 18x minus 81. And again, we could go through that whole process, find the GCF here, which looks like it's going to be a 2x, and you're left with 2x plus 9. The GCF here would be a negative 9, and you're going to be left with 2x plus 9. Take out the 2x plus 9 now, and you're left with 2x minus 9. But guess what? I'm not going to make you do all this. All you've got to do is, if you've got two perfect squares, just take the square root of each term and put one with a plus and one with a minus. 4x squared is a perfect square. X squared is and 4 is. What's the square root of 4x squared? 2x. 2x times 2x gives you 4x squared. What's the square root of 81? 9. Make sure you put a plus on one and a minus on one, and you're done. So even if they throw an a value in there, you can always do it the long way. The long way always works here. But you can also do the shortcut way, which is just square rooting. So what if you had 100x squared minus 625? Yeah, this is where I really wouldn't want to do the long way, because 100 times 625 would be 62,500. I just don't want to mess with those huge numbers. I need to ask myself, is this a special case? First of all, if you are given a binomial to factor, that's weird. Normally we have trinomials. So if you're given a binomial, ask yourself, is this one of those special cases Miss Heim told me about? Is it the difference of two squares? Is it a difference? Are these perfect squares? Yes, I don't have to go through that process. I take the square root and the square root. What's the square root of 100x squared? 10x. What's the square root of 625? 25. And one's a plus and one's a minus. Could I go through that long process? Absolutely. Would it be fun on this one? No, it wouldn't. So you need to recognize the difference of two squares when you see it. That's pretty much the hardest part about this. Also, they might do this to you. They might put it backwards, like 121 minus 9x squared. Don't even try to rewrite it. You know what? We just want to factor it just like it is. Are those perfect squares? Are they being subtracted? What's the square root of 121? 11. Now, since 121 was in the front, you put the 11s in the front, right, Kristen? What's the square root of 9x squared? 3. X. So since that was written on the back, you put it on the back. One's a plus and one's a minus. You don't want to rewrite it because the X's should have the negative sign with it, not the 11s. The 3 X's, one of them should be negative and one should be positive. Both of the 11s should be positive. So you don't want to try to rewrite it. If it's written backwards, factor it backwards. No big deal. So guess how long this assignment's going to take you? Yeah, not long at all, especially with that list of perfect squares that I gave you at the beginning. Right? Now, your homework, because I want to make sure you're experts at factoring and because that's just way too easy for people as smart as you, I'm giving you a little bit of both here. You're going to do page 181, and this is not going to take you long at all. 1 to 33, first column. That's only 9 problems. And then 5 or 6 more, on page 178, 2 through 17 in the second column. We already did the first column on this page. That's a total of 15 problems, and the first 9 will take you about a second apiece. So I'm really only adding like 6 problems to your homework here. And you're going to have plenty of time to get started in class. Oh, you know what I forgot? Back up. I forgot. Jason asked a very good question. This was the other... Oh, sorry. I'll go back to the homework. There was one more special case. This isn't going to take long, and it's not even on your homework tonight, but you will encounter this second special case. Okay, so there's your homework. Will somebody write that on the sideboard over there for me? Okay, one more special case for you. Again, this is not normal. If you're asked to factor a binomial, that means you're only given 2 terms. That's not a normal situation. We just learned about a special problem called difference of 2 squares. Here's another special case. Okay, this is when all you can do is GCF. Look at this problem. If you're asked to factor completely and your problem looks like this. 2x squared minus 10x. And our directions are to factor. That is a binomial. It's not normal to be asked to factor a binomial. Normally we're asked to factor trinomials. Are y'all looking up here? What's missing in this problem? The c. This has an a value of 2, right? What's the b value? No. Negative 10 is the b value. And there's no c value. The c value is like a 0. The only way you can factor this problem right here is to take out a GCF. Sometimes GCF is all you can do. This is not going to factor into 2 binomials like normal. This is going to factor into a GCF times whatever is left. So if you're missing the c value, usually all you can do is GCF. What is the GCF of these 2 terms? 2x. So I would factor out a 2x, and what would I be left with? X minus 5. That's all you can do on that case. That's the answer. So this is a different type of special case. Sometimes all you can do is take out a greatest common factor, and then you're done. This will not factor into 2 binomials. It's in a monomial times what's left from the binomial. If there's no c, there should be a GCF. Like this one, x squared minus 2x. What's the GCF here? Guys, look up here. You will see this. You will have to know how to do it. It's not the difference of 2 squares. That's what a lot of kids think anytime they see a binomial. They think it's the difference of 2 squares. It is a difference, but 2x is not a perfect square. And we're not missing the b value here. We're missing the c value, what we just talked about. We have an a of 1. We have an a value of 1. We have a b value of negative 2, but we don't have a c value. If you don't have a c value, you cannot factor it like normal. This is just a GCF problem. What's the GCF here? Yeah, x is the GCF. You take out an x and you're left with x minus 2. That's how you factor that, and you're done. So 2 special cases today. Difference of 2 squares, and also the case where all you can do is take out a GCF sometimes. All right, get to your homework. Those of you who are absent, I'm going to put the quiz back up.